Good morning, guys. So I want us to do assignment 6. So the question started by describing what the mechanism is about. So we are moving a product or a rectangle from here. That's R1, S1, T1, K1 from conveyor 1 to conveyor 2. So this is position 1. This is let me write it position 1. Okay, I think so. This is position 1. This is position 1, this is position 2, and this is position 3. So we are moving something from here to position 3. So, and then in the question it says D and C are the attachment points. So, but you see, at position 2, there are no attachment point at position 2. So we use triangulation to get B and C on this attachment point for position 2. So to triangulate, you stand at R1 and then you open your compass to C1. So you measure the length from here to here with your compass, R1 to C1. And then you measure that length and then you come and stand on R2. And then you make an arc. You make an arc here. After that, you come and stand at S1 again. And then you measure the length from S1 to C1. That's the triangulation. S1 to C1. And then you come and stand at S2. S2. You draw an arc again. So you draw an arc here. You draw an arc. You triangulate. So that means we have transferred this point S1 R1 C1 to S2 R2 C2. You see, so here we C2. So we do same for D2. So we measure the length from here R1 to D1. We measure that length. We go and stand at R2. We draw an arc to that point. We will draw an arc here. Draw an arc over there. And then you stand at S1. You open your compass to D1. You take that length. You go and stand at S2. And then you draw an arc. Where the arc intersects the line from R2. That's where you're going to get your D2. So after getting D2, now we can start the question because now we've gotten the attachment point for position 1, position 2, and then position 3. So the question, it says we should join the line or the D3 to D2 and then from D2 to D1. So let's do that one. So I'm joining D3 to D2. After that, wait, sorry, let me use a different color. So let me say green. I'm using green. I'm joining D3 to D2. After that, I'm going to join D2 to D1. I'm using green lines for that one. I hope you can see the difference. Yes. So I've joined D3 to D2 and from D2 to D1. Now I'm going to bisect D1, D2 and then bisect D3, D2. So you know how to bisect a line, perpendicular bisector. You stand at D1, you open your compass more than half, you draw an arc over here, you draw an arc over here. You come and stand at D2, you open your compass more than half, draw an arc over here, you draw an arc over here, and then you draw a line to pass through the center of the two lines to get your perpendicular bisector of line D2 and then D1. And I recommend that you write it on it D2, D1. So I've written the lines are bisected or the points are bisected on the perpendicular bisector. After that, we are going to bisect D3 and then D2. So you stand at D2, you open more than half, you draw an arc, you draw an arc. You stand at D3, you open more than half, you draw an arc, you draw an arc, and then you draw a line to pass through the 2 points. That is going to be your Sorry for my arcs, but I hope you get the concept. So that's going to be, so this line you label it D3 B2 so that it doesn't confuse, you don't get confused, because you're going to draw the same thing for C3, C2, and then C1. So we label this point for the D in the question. It says the pivot for the D should be O6. For the D, the perpendicular bisectors of the D should be O6. So we are going to do the same procedure for C3, C2, and then C1. So let me use red, a color red. So I'm going to use this red color. So for C3, C2, and then C1, you join C3 to C2 like this with a straight line. And then you join C2 to C1 also with a straight line. So after that, you are going to bisect C3, C2, and then C2, C1. So let's start from C1. You stand at C1, you open your compass more than half, you draw an arc, you draw an arc. You stand at C2, you open your compass more than half, you draw an arc, you draw an arc, and then you draw a line to pass through it. That's your perpendicular bisector. Yes. So you've got a perpendicular bisector. And after drawing the line, you name it so that you don't get confused with the other lines. C2. So this one will be C2, C1. That's the perpendicular bisector of these two lines. And now we are going to bisect C3, C2. So you stand here, you open your compass more than half, you draw an arc, you draw an arc. You stand at C2, you open your compass more than half, you draw an arc, you draw an arc. And then you draw a line to pass through it. So you're going to get another perpendicular bisector of this line. And then you label this line to C3, C2. That's the perpendicular bisector of that line. And so now you label the pivot where they meet at O4 in the question. In the question. Oh, sorry. In the question, that is what. Oh, sorry. Okay. So in the question. So now we've gotten the pivot. We've gotten the pivot, which is O4 and then O6. So O4 is for C's. See, O4 is coming from the perpendicular bisector of C2 and then C1, and then as well as C3 and then C2, and then O6 is coming from the perpendicular bisectors of these two lines, which is D3, D2, and then D1, D2. So after that, now we are going to join for the O4. Let me use the red color. Yeah, it's even red already. So we are going to join O4 to all the C's with short dashes from the question. So short dashes like this. To C1, I join O4 to, you see O4, we got O4 by bisecting the C lines. So we are going to join everything from the O4 to the C. So I've joined from O4 to C1. I'll join from O2 to C1. And I also join from O3 to C. No, I'll join from C3 to O4. Oh, okay, sorry. So now I've joined these short dashes is in the question. So I've joined all the attachment point from C3, C2, C1 to the pivot O4. And I'll do same for the pivot O6. But O6, we obtain O6 by bisecting the D lines, which is D2, D3, and then D2, D2, D1. So that one, let me use a green line, a green pen. So short dashes from here to here, and then D2 join from here to here. I don't know if, but try as much as possible to see what I'm doing. I want to erase, but my erasers, I don't know. I don't know. Let me try and erase some of the lines here so that you can see the arc lines. Okay, sorry. So that you can see what is really happening. Okay, I think this is much better. So, okay. So join from D. Yes. So look at the green lines. All the green lines are for D, and all the red lines are for C. Okay. So now after that, the question says you should measure angle C1 04 C3. You should measure C1. This is C1. C1. Oh, sorry. Let me use um, a red a red pen. We should join C1. This is C1 04 C3. We should measure this angle. So this is the angle we are going to measure. You're going to measure from here to here. That is the angle C1 04 C3. After that, we will measure um, D1 06 D3. So you're going to measure D1 06 D3. That is also the angle from here to here. Yes, so you're going to measure, sorry, that's also the angle from here to here. So you're going to measure these two angles. And um angle angles, no, let me use a black pen for that one. So angle C1 04 C3. I got 111 degrees, and then angle D1 06 D3 D3. I got 129 degrees. 129 degrees. So if you are doing this assignment, you are going to get something closer to that. Okay. So after that, you are going to add a non-quick return driver diode. So we always attach the diode to the smallest angle as possible. Yes. So since C1 04 C3 is the smaller angle here, we are going to attach the diode to this angle. Yes, but there is something that we have to do. We have to, in the question, there was a condition that the diode should be horizontal. The diode should be located horizontal to the rocker. So to draw the diode horizontally, this is what we are going to do. I really want to erase these parts. I don't know. So let me see. Just stay there for me. I really want to erase this part. How? Okay, stay with me. Stay with me. I just want to erase these lines. I don't know why my eraser is acting like that. The eraser I'm using is a stroke eraser, so every line that it touches, it just erases the whole line. But just stay with me. I want you to get a concept. I want to align the diode horizontally. So if you want to align the diode horizontally, I'm going to erase these two lines. But stay with me. Okay. So let's pick the red pen. So to draw the diode horizontally, you are going to draw a vertical line. You see, the diode is going to be attached to this angle here. So you draw a vertical line here, and then you measure the angle. So I got 111. So that angle is 111. 111 divided by 2 will give me 55.5. So 55, you put your protractor on this line. So you align your protractor like this. I'm showing you how you are going to measure it. You align your protractor like this. You see, you align your protractor like this, and you ensure that the 90 mark is in line with this vertical line that you drew. Okay. So now you are going to measure. You see, we divided this the angle here into 2. So this angle, I got 111. So 111 divided by 2, you get 55.5. So with this 55.5, you are going to stand at the 90 mark. This will be the 90 mark if you align the protractor like this. And then you are going to measure 55 to this side. So let's say 55.5, I got this point, and then 55.5, I got it also on this other point on the protractor. And now you remove the protractor. So I'm going to remove the protractor. Now I've removed the protractor. Now you draw a line to pass through that 55 mark. Yes, so you draw a line to pass through it. And then I want to erase 04 so that we can see the line clearly. So you draw a line to pass through that 55 mark. Okay, but there was a restriction that the dash should stay within the the box or the square. So I think it should not extend. Okay, you can extend it actually. You can extend it, but you ensure that the arbitrary radius or the arbitrary length where you are going to draw the coupler should stay within this enclosed M, this enclosed square M, L, P, and then N. It should stay within it. The diode and then the coupler, all the moving parts should stay within it. Yes. So you stand at this point with your compass, you open to any arbitrary radius, and then you draw an arc. Draw an arc here, and then you draw a line to pass through this the arcs. Yes. So you see, I got a horizontal line. You should get a horizontal line. You should get a horizontal line if this line is vertical. If you draw a vertical line here, and it's actually a vertical line, you are going to get a horizontal line. And so now we can measure the length from here to here, and that will be the radius for our diode. So you come and stand at any point here, and then you draw your diode. So this is it. This is the whole thing that the assignment is requiring from us. And then there are some measurements. You measure transmission angle. So transmission angle is the acute angle between the coupler and then the rocker. So in this example, the rocker is from here to here. That is the rocker. And then the coupler is, okay, let me label that. So in the question, it says this part should be O2. And then here should be A1, A2. And then here should be B1, B2. So now the coupler is from A2 to B2. That is your coupler. And then your crank is A1 to O2. And your rocker is B1 to O4. You see, here is O4. So that is the construction part of it. I think you calculate some angles. And then there was a condition. You see, there's a condition that if the in this question actually, this link, okay, I think because I use a freehand sketch, that condition, that limitation cannot be seen here. But after doing the actual work, there will be a situation where from O4 to C3 will intersect O6 to D3. And so when that happens, we are going to bend the length or the length O4 to C3. We are going to bend it because that length should not, you see, there is a pivot. Actually, if 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 you should follow the steps I did over here, O6 is going to be somewhere here. Let me use the green red. So O6 is going to be somewhere here. Yeah. You are going to get O6 here. And if O6 is here, so that means O4 to C3 will pass over O6, which is a pivot. And a linkage or a link cannot pass over a pivot. So if that happens, then we have to bend this link in a way that it won't pass. Okay, so this is what I'm saying. So you see, if O6 should be here, if let's say here is O6, so that means O4 to O3 will pass over O6. And if it's going to pass over O6, that means we can't build the actual mechanism or the working model. This is the construction. The construction, you can see there's a problem over there. But if you want to build a thing, actually, like you want to create a 3D mechanism, it won't work. So what we are going to do here is we are going to bend this line like this. Yes. So this is going to be C1. C1, we are going to bend C1. So now C1 won't start from here directly to here. C1 is actually going to start from here and then bypass over the pivot. This is going to be the actual line of C1. Yes. Yes. So that's the only limitation, and that's what the question was saying. The question was saying that if there is a limitation or a constraint where one link passes over a pivot, then you have to redesign the link. So O6, O4 to C1 passes over a pivot. If you should do it the right way, you are going to see that O6 will pass over the link O4 to C1 will pass over O6. And if it's going to pass over O6, you have to bend O4 to O6 so that it does not pass over it. Because if it passes over it, it cannot pass over it. So that means the mechanism cannot complete the toggle position. It cannot complete that 111 degrees. No, because there's a pivot here. You see, the angle from here to here is 111. From here to here is 111. But if there is a pivot here, we cannot complete that 111. So that means we have to bend this link so that it skips over that pivot. So now, so that means all the links are going to be bent. So this is the link O4 to C1, and then this is going to be the another link for um, O4 to C2. Oh, sorry. So O4 to C2 is going to also be like something like this, and then O4 to C3 is also be like something like this. So this link here, this link here, this link here, and then this link here is what the question was saying, that if there is going to be a pivot that's going to obstruct the movement of O4 to C1, redesign the link. And so this is the new design. Yeah, so that's all. So let me go back and show you the actual construction. Okay, so that's all. Thank you for watching and see you in the next one.